Hello guys, welcome to this lesson about Euclidean geometry. It is the third lesson that I'm presenting, and if you have not watched the other two, please do so. Well, they are at different levels, but it is the same topic. Okay, so in this one we have this question, and let us have fun and engage, right? I believe you have something to write with and to write on, and I trust that this video will help you elevate your understanding of mathematics as far as geometry goes. So ABCD is a parallelogram. Okay, so when you're given the name of the quad, it means you have the right to use the properties of that quad. Okay, or any shape for that matter, like even in the case of triangles. Okay, E and F are points on AB and DC respectively, such that AE is equal to CF, very important. DE is produced to J and CJ is drawn. BF is produced to K, and then AK is drawn. Okay, when you produce a line segment, it's just the same thing as saying extending a line. Okay, so in that process, you form an exterior angle. Okay, so very important to know that the word produce is just like saying extended. Okay, so let's start with what we have noted, parallelogram. Okay, we know that opposite sides are parallel and equal. Okay, so that is parallel to that, and again, they are equal. Good. AD equal and parallel to BC. Okay, so double arrow for those two, distinguish them, and again they are equal. Enough said about the sides. What can you say about the interior angles? Interior angles are equal. Angle A1 plus A2 must be equal to angle C1 and C2. Okay? Angle D1 plus D2 is equal to angle B1 plus B2. Okay, and then what do we have? Diagonals. However, here they're not drawn, so it's irrelevant for us to talk about the diagonals. Good, so we have parallel lines, and obviously we can make use of the fact that alternate angles, corresponding angles, and co-interior angles will be present because we have parallel lines. Okay, it is one of that or a combination of that. Okay, so look at the first question here. Prove that DJ is parallel to KB. So DJ is this line, KB is that one. So we want to prove that these two lines are parallel. Okay, so what would be the best approach here? We have this condition, AE is equal to CF, AE equal to CF, but they are very far apart, they're split. We also know that AD is equal to BC, okay, and we have A1 and A2 equal to C1 and C2. What does that help us with? What does it trigger? Yes, congruency, right? Side, angle, side in this case. So we have a side equal to a side. We have an angle equal to an angle. We have a side equal to a side. So through that condition, we're going to now prove that these two triangles are congruent. And from congruency implies equality of angles and sides. We can now introduce angles that are equal, and from the angles, we can now prove that these lines are parallel. I believe you've got the road map. Okay, so I'm gonna use what? Red. Okay, so in triangle AED and triangle CFB, what is happening? We know that angle, or let's start with this given sides. We know that AE is equal to CF, this statement right here, It was given, right? And then we know that AD, yes, is equal to BC, and this is opposite sides of a parallelogram are equal. Following, okay? And the last thing to talk about is the angles, okay? Angle A1 plus angle A2 is equal to angle C1 plus angle C2. Or you can just say angle A is equal to angle C, the whole angle there at point A and C respectively. And these are what? Opposite angles of a parallelogram are equal. So by side angle side, we've proven that these two triangles are equal. I mean, not equal, sorry. They are congruent, and congruence implies equality of sides and angles. Therefore, triangle AED, A is congruent, remember? 3 horizontal lines, okay, to triangle CFB by side angle side condition of congruency. Okay, so now what do we want to achieve? If we can now prove that D1 is equal to F3, then we will have the fact that these two lines are parallel. Okay, but then what do we know? We know that angle E3 here must be equal to angle F3. And E3 is vertically opposite to E1, and E1 is corresponding to D1, and therefore we can now say D1 through that process will be equal to F3, and in that way they will be equal. Oh, the two lines will be parallel. Okay, so from here we can now say angle E3 is equal to angle what? F3. Why? Because we have congruent triangles. Good. So we've spoken about this angle here, E3 and F3. Now I'm going to talk about this. Angle E1 is equal to what? Angle D1. Okay. So angle E1 is equal to angle D1. Okay, they are corresponding angles because AB is parallel to what? DC. Okay, but what can you say about E1 and E3? However, E1 is equal to angle E3. Okay, they are vertically opposite angles. So the same thing equal to two different things. So what can you say about these two different things? They are equal. So therefore, angle D1 is equal to angle what? E3. Sorry, angle E3. Now connect it to that. What did you say in this line? You said E3 is equal to F3. Here you are saying E3 is equal to D1. So D1 is equal to F3. That is what we wanted to prove. So therefore, angle D1 is equal to angle F3. Okay, and therefore DJ is parallel to KB. What type of angles are these? We have said D1 now is equal to F3 because corresponding angles are equal. Okay, so the essence here was to talk about congruency. From congruency, equality of angles. From equality of angles, the connection of your D1 and F3 to form now or to prove that there are parallel lines DJ and KB. Okay, good. Now we want to talk about B. Prove that angle E1 is equal to F1. E1 is right here. Already we know that it's equal to D1. It's also equal to F3. But F1 is here. So the only thing we need to now prove is to say that indeed F3 is equals to F1. Why? Vertically opposite angles. And then we work our way back to E1. Okay, so we know that F3 is equal to F1, and this is by vertically opposite angles. Okay, but then we know that F3 again is equal to what? E3. And what did you say about E3? It's equal to E1. Okay, but then F3 is equal to E3. This was proven in the previous question. Okay, so again we know that E1 is equal to E3. Okay, and we know that angle E1 is equal to angle E3. Okay, so again this was proven in the previous question. So the same thing equal to two different things. F3, angle F3 will now be equal to angle F1, but angle F3 is equal to F1. So therefore, angle E1 is equal to angle F1. And that will be enough proof there. All right. So guys, this is Euclidean geometry. There are a lot of contexts that we can investigate and check, but really it is doable and you can do it, and it just comes with practice and getting yourself into a consistent effort in the mathematics of practicing this type of questions, and training your brain or your mind to be able to see connections and bringing the knowledge there to help you be effective. So thank you for tuning in, and all the best. I'll see you next time. Shap shap.